Welcome to G Fun Facts Online. Today we are diving deep into a subject that has fundamentally shattered our understanding of the solar system in the last decade. For centuries, humanity looked at the cosmos as a static tapestry. We viewed our solar system as a closed loop, a clockwork mechanism of planets, moons, asteroids, and comets that were forever bound to the sun. We believed that everything we saw in our night sky, save for the distant stars themselves, belonged to us. We were wrong. The cosmos is not a museum. It is a dynamic, churning ocean where worlds are born, destroyed, and occasionally cast adrift. In the last few years, we have woken up to the fact that our solar system is being bombarded by visitors from the dark spaces between the stars. These are the Interstellar Objects, or ISOs. They are celestial nomads that have broken free from the gravitational chains of their parent stars to wander the galaxy for eons. In this episode, we are going to explore the definitive story of these cosmic interlopers. We will cover the baffling arrival of Oumuamua, the ghostly chemistry of Borisov, and the sensational discovery of 3I Atlas in July 2025. We are going to look at the science, the mystery, and the profound implications of these visitors. Are they mere rocks? Are they the seeds of life? Or could they be something artificial? Let's unlock the secrets of the wanderers of the void. To understand the magnitude of this shift, we have to look at the pre-2017 paradigm. Before October 2017, the concept of an interstellar object was purely theoretical. Astronomers knew they must exist. Planet formation is a messy business. Computer simulations of our own solar system's youth suggest that as Jupiter and Saturn migrated, their gravity kicked trillions of icy bodies into the deep freeze of interstellar space. Logic dictates that if our sun did this, then every star with planets must do the same. The Milky Way should be teeming with these ejected orphans. Yet we had never seen one. For all of human history, every comet and asteroid we tracked followed an elliptical orbit, meaning they were bound to the sun. We were like islanders who had never seen driftwood from another continent, assuming the ocean brought nothing but its own waves. That changed on October 19, 2017. The Pan-STARRS-1 telescope in Hawaii, designed to hunt for dangerous near-Earth asteroids, flagged a faint point of light moving at a furious speed. It was moving at 87.3 kilometers per second relative to the sun. That is a velocity that makes it impossible for the sun's gravity to capture it. It had come from the direction of the star Vega, swooped past the sun, and was already on its way out, never to return. They named it 1I, Oumuamua, a Hawaiian term roughly translating to a messenger from afar arriving first. It was the first confirmed visitor from another star system. But as data poured in, the celebration turned to confusion. Oumuamua remains the most controversial object in modern astronomy. When astronomers trained their telescopes on it, they expected to see a coma, the fuzzy cloud of gas and dust that surrounds comets as they warm up. Comets are the most easily ejected objects from planetary systems, so statistically, the first visitor should have been a comet. But Oumuamua was dry. There was no tail, no gas, no visible dust. It looked like an asteroid, a chunk of rock or metal. This was the first anomaly. Then came the shape. As the object tumbled through space, its brightness fluctuated wildly, dimming and brightening by a factor of 10 every 8 hours. This implied a shape unlike anything seen in our solar system. It was either a cigar shape, 10 times longer than it was wide, or a flat pancake-like disk. Nature rarely produces such extreme ratios. But the real smoking gun was its movement. As astronomers tracked its exit trajectory, they realized it was accelerating. Gravity from the sun and planets dictates the path of all objects, but Oumuamua was being pushed by an extra, non-gravitational force. Comets do this via outgassing, where jets of steam act like thrusters, but Oumuamua had no visible jets. This led to an explosion of theories. Was it a hydrogen iceberg that was sublimating invisibly, a dust bunny of ultra-porous material pushed by sunlight? Or, as Harvard astrophysicist Avi Loeb famously suggested, was it artificial, perhaps a light sail or defunct probe from an extraterrestrial civilization? While the scientific consensus leans toward natural exotic explanations like nitrogen ice, which would be invisible to telescopes as it evaporates, the alien artifact hypothesis has embedded Oumuamua in the public consciousness forever. 2 years later, just as the debates were settling, the second visitor arrived. Discovered in 2019 by amateur astronomer Gennady Borisov, the object designated 2I/Borisov was the normal sibling to Oumuamua's weird cousin. Borisov was unmistakably a comet. It had a beautiful, ghostly tail. It looked, acted, and smelled like the comets from our own Oort cloud. This was a relief to many scientists, as it proved that our models of planetary ejection were largely correct. However, Borisov had its own secrets. Spectroscopic analysis revealed it was incredibly rich in carbon monoxide and cyanide. Its carbon monoxide abundance was far higher than most solar system comets. This suggests it formed in a region much colder and darker than our own Kuiper belt, perhaps around a red dwarf star or in the frigid outer rim of a massive protoplanetary disk. Borisov was a pristine sample of an alien deep freeze, unchanged for billions of years until it warmed up by our sun. Then came July 2025. The Atlas survey picked up a new hyperbolic target, designated 3I Atlas. If Oumuamua was the rock and Borisov was the ice, 3I/Atlas is the history book. Current analysis has revealed it to be a massive, active body, larger than both its predecessors. What makes 3I/Atlas sensational is its trajectory and composition. It is incoming with a velocity that suggests it originated from the thick disk of the Milky Way. This population of stars is ancient, formed early in the galaxy's history. Preliminary studies indicate 3I/Atlas could be 11 billion years old, twice the age of our solar system. It is a relic from the dawn of the galaxy. Spectrometers have detected water vapor and signs of cryovolcanism, or ice volcanoes, erupting from its surface as it feels the heat of a star for the first time in eons. 3I Atlas is not just a visitor, it is a time capsule, carrying the chemical fingerprint of the universe before Earth even existed. The existence of these three objects implies a staggering reality. Based on the detection of 3 objects in less than a decade, astronomers now estimate that at any given moment, there are likely 10,000 interstellar objects passing inside the orbit of Neptune. We are swimming in a shoal of interstellar fish, but we only see the ones that jump near the boat. But how does an entire world get kicked out of its home? The primary mechanism is gravitational scattering. In a young solar system, giant planets like Jupiter act as bullies. Their immense gravity clears their neighborhood, flinging smaller debris around. If a planetesimal passes too close to a gas giant, it can gain enough energy to exceed the system's escape velocity. It is banished into the dark. But not all ISOs are born from peaceful formation. Some are refugees from destruction. Supernova can blast planetary systems apart. Tidal disruption events, where a planet wanders too close to a black hole or white dwarf, can rip worlds to pieces. In fact, Oumuamua's elongated shape fits the model of a fragment torn from a larger planet by tidal forces. Even the expansion of red giant stars can destabilize orbits and shed material into the galaxy. This leads us to one of the most tantalizing implications of ISOs, panspermia. This is the theory that life exists throughout the universe and is distributed by space dust, meteoroids, asteroids, and comets. Before 2017, panspermia was difficult to model because the transfer rate between stars seemed too low. But if the galaxy is awash with ISOs, the math changes. Imagine a large asteroid impacts a life-bearing planet like Earth. Rocks containing hardy microbes are blasted into space. Eventually, these rocks might be ejected from the solar system entirely. They freeze, preserving the bacteria, or DNA inside, in a state of suspended animation. Millions of years later, this object enters a new solar system, collides with a habitable planet, and seeds it. The discovery that 3I/Atlas is releasing water vapor is critical here. Water is the matrix of life. If objects like 3I/Atlas are common, they are carrying vast reservoirs of water and organic molecules from star to star. Even 2I/Borisov was rich in cyanide, which is a poison to us, but a key precursor for prebiotic chemistry like amino acids. While finding active life is unlikely, finding the complex organic sludge that leads to life is a very real possibility. So, how do we catch them? We are currently in the golden age of ISO detection. The game changer is the Rubin Observatory in Chile. With its massive mirror and the largest digital camera ever built, it scans the entire southern sky every few nights. Unlike previous telescopes that had to know where to look, Rubin watches everything. It is predicted to find not just one ISO every few years, but potentially dozens per year. By 2030, we could have a catalog of hundreds of interstellar visitors. But finding them is one thing, visiting them is another. The problem is speed. They move too fast for a rocket to catch up to them once they are discovered. By the time we launch, they are gone. Enter the Comet Interceptor, a mission by the European Space Agency and JAXA. Scheduled for launch in 2029, this spacecraft will not wait on the launch pad. It will launch and travel to the Sun-Earth Lagrange Point 2, a stable parking spot in space. There, it will wait like a hunter lying in ambush. When a pristine ISO enters the inner solar system, the Comet Interceptor will activate its thrusters and alter its trajectory to intercept the target. It will split into 3 smaller probes to photograph the object from multiple angles, creating a 3D model of a world from another star. We cannot conclude a discussion on ISOs without addressing the technosignature hypothesis. Harvard's Avi Loeb has argued that we must not assume natural origins by default when the data looks anomalous. He points out that Oumuamua's shape and acceleration are consistent with a solar sail. While the mainstream community prefers natural explanations, the debate has forced a healthy expansion of our minds. The Galileo Project, founded in 2021, is explicitly dedicated to searching for physical artifacts. They are not looking for radio signals like SETI, but for physical objects near Earth that could be extraterrestrial equipment. Even if Atlas is a comet, its presence reminds us that things can travel between stars. If a rock can do it, a probe can do it. Consider the Sentinel hypothesis. If a civilization wanted to monitor life in the galaxy, they wouldn't send radio waves that fade over distance. They would send autonomous probes to lie dormant in planetary systems, waking up only when they detect technology. Could an ISO be such a probe? It is speculation, but it drives the scientific curiosity to look closer. The study of interstellar objects has fundamentally changed our cosmic perspective. For eons, we studied the stars from afar, analyzing their light. Now the stars are throwing rocks at us. Each ISO is a physical piece of an exoplanet system. Oumuamua was a shard of a broken world. Borisov was a pristine snowball from a dark alien nursery. 3I/Atlas is an ancient traveler from the galaxy's youth. They bring us matter, atoms, molecules and ices that were forged in alien suns and frozen in alien clouds. It is statistically probable that Earth, in its 4.5 billion-year history, has been struck by interstellar objects. It is possible that some of the water in our oceans, or the carbon in our bodies, originated in a solar system on the other side of the Milky Way. We are not isolated. We are downstream from the rest of the galaxy, catching the driftwood of a billion other worlds. The era of interstellar geology has just begun. We no longer need to build warp drives to visit other star systems to know what they are made of. We just need to wait. The galaxy is coming to us. Thanks for listening to G Fun Facts Online.